Welcome back, Wolfpack, and welcome to Lesson 4.3, Medians and Midsegments of Triangles. Our essential question continues to be, how do triangle properties assist in solving real-world problems? Let's get started right away on some vocabulary. The median, think about the median in a road, the middle. The median of a triangle is a segment from a vertex to the midpoint of the opposite side. So it goes from the vertex, from a point, to the midpoint, or the middle of the opposite side. The medians of a triangle intersect at a point called a centroid. So every triangle has 3 medians, and where those medians meet is called a centroid. And the centroid is also called the center of gravity. So the median is the middle, it intersects the other side. Every triangle has 3 of them. The centroid, or where the 3 medians meet, the center of gravity, is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So we're going to be dealing with fractions here. So 2/3 of the distance. So if you notice, we're going to look at A. So from A, a median is drawn to BC, okay? And that median divided BC up into 2 pieces, here and here. So XC is equal to XB. The median, AX, divided BC into 2 equal pieces. And where all the medians meet, so from B to AC, and from C to AB, where they all meet, that's called the centroid. And the centroid is 2/3 from the vertex to the opposite side. So this yellow dot is 2/3 of the way from C to Z. So this would be 2/3 on the left side, 1/3 on the right side. Example 1. In triangle ABC, the median AD is perpendicular to BC. If AD is 21 feet, describe the position of the centroid. So AD is 21 feet. Okay, that long line, I'm having a hard time drawing right on top of it. Well, the centroid is 2/3 of 21 feet. Okay, it's not halfway, it's not half of 21, it's 2/3 of 21. So the centroid is 2/3 times 21, so 2 times 21 is 42. 42 divided by 3, 42 divided by 3 is 14 feet. So the centroid is at 14 feet. Okay? At 14 feet. It's 2/3 of 21. Example 2. Use the centroid theorem to find the following lengths. If AF is 9, so this position is 9, and CE is 7.2, find AG and GE. Okay. So AF is 9. Well, AG is from A to G. Okay, so it's 2/3 of AF. So AG is 2/3 of AF. AG is 2/3, and we know that AF is 9. AG, 2 times 9 is 18, divided by 3, which is 6. AG is 6. So now we're going to do GE. And I'm going to erase this so we can see a little bit again. So we had CE from C to E, and I actually should draw it from C to E to make it a little bit more clear. So from C to E is the median, and they want GE. So they want from the centroid, which is right here, to the remainder. So we're not looking at 2/3, we're looking actually at 1/3. Okay, so GE is 1/3 of CE. If they said they wanted CG from the vertex to the centroid, that'd be 2/3. But they went from the centroid to the side. We're not going to a vertex, we're going to the side. So that's that other 1/3. So CE was 7.2. So I need 1/3 of 7.2. GE is 1/3 of 7.2. And if you have a calculator, it's 1 times 7.2 and then 7.2 divided by 3. GE is 2.4. So you're either dealing with 1/3 or you're dealing with 2/3. If you're finding from the vertex to the centroid, you're looking for 2/3 of the distance. If you're finding, oh, I just boxed in the wrong thing. If you're finding from the centroid to the side, that's 1/3. That's the remainder. Okay. Let's look at, we'll do example 2B in class together. Next up, we have the midsegment. The midsegment of a triangle is a line segment that connects the midpoints of its two sides, and every triangle has 3 midsegments. 3 medians, 3 midsegments. So the midsegments go from side to side, not from vertex to side. The triangle midsegment theorem states that the segment joining the midpoint of two sides of triangles is parallel to the third side, and its length is half of that side. So for example, DE is a midsegment because it cut BA in half. BD is equal to DA. And it cut BC in half. BE is equal to CE. And it's parallel to the third side. So if the bottom is 10, that would mean that the midsegment is half of that. DE would be 5. So a survey, let's do example 3. A surveyor needs to measure the distance PQ across the lake. Beginning at point S, she locates the midpoints of SQ and SP at M and N. She then measures NM. What is PQ? So since we know that this is the midpoint, okay, cut it in half, cut this in half. She then measures NM. Sorry, M cut it in half. My apologies. So we know that the midsegment is half of the side that it's parallel to. Well, 78 times 2, 156 meters is the answer. We double the midsegment. And we will have the answer. Okay, the midsegment is half of the third side. We will do examples 4. You know what, we will do the rest of this in class, I think. Definitely example 4. Let's look through. Example 4 we'll do in class. Oh, my screen's not switching. Example 4 we'll do in class. Example 5 we'll do in class. Example 6 we'll do in class. We can do this triad, though. And no one, I'm sorry, we're going to go into the triad class. That's a lot. We learned a lot of vocabulary here with between centroids, medians, and midsegments, so I'm actually just going to stop right here. Appreciate you guys being flexible. So, as a recap, we learned about the median. The median goes from the vertex to the other side. Where all 3 medians intersect is the centroid. We also learned about the midsegments. The midsegment goes from side to side. It's parallel to the bottom side, and it's half of its length. We found an example here. NM was 78. We doubled it to find the third side. And then the rest of these problems we will do in class. Hope you guys have a great day, Wolfpack, and I will see you next class period.